Hi class, let's take a look at example 6, and for any of the actual equations, you're basically plugging in a couple of coordinate points and you're using your calculator to evaluate these. Some of these could be really messy. So for example, let's look at a couple of these values. So I'm just going to create a table. So this is going to be our angle, and then we're going to have, well, r is equal to 1 minus cosine of theta, and then we're going to be evaluating or collecting, well, r comma theta. So keep in mind that your coordinate point is r theta, so that we don't accidentally put it backwards. So these are the coordinate points that I want to evaluate, just so that we get an idea of what this one looks like. So let's actually start at 0, and then maybe a pi over 4. We could do a pi over 2, and then we can stop it at pi. If you remember what these look like, I would still like for you to plug in a couple of coordinate points. It's very easy to mess these up just because of the actual minus. Could put them on the, instead of the second quadrant, on the fourth quadrant or something like that. So please plug all of these in. So we're talking about r is equal to 1 minus cosine of 0. R is equal to 1 minus cosine of pi over 4. R is equal to 1 minus cosine of pi over 2. And then r is equal to 1 minus cosine of pi. Okay, so let me tell you what I'm getting for each of these. If you get a messy decimal approximation, that's actually fine. So for the first one, I'm getting, well, cosine of 0 is 1. So technically I'm getting 0. So 0 comma 0. And remember that these are not rectangular, these are polar. So technically the first coordinate point, it's going to be at the origin. The second one, well, as a decimal approximation, I'm getting, I'll say 0.29, rounding to 2. So we're going to look at 0.29 and technically pi over 4. So I'm just going to say that this is 1, 1. So at a radius of 0.29 and then pi over 4, it's going to be around here. Okay, next one is going to be pi over 2. And I'm getting that this is, actually, wait, cosine. Let me double check this one. Yeah, I'm getting 1. So this one's going to be at 1 comma pi over 2. So technically it's here. And then the last one's going to be at pi. So that's going to give us a -1. So this will be just 2. Let me confirm it. So we're looking at 2 comma pi. So technically this is going to be 1. That's going to be 2. And let me just put the coordinate points with a different color. So we're looking at this one here, that one there, there, and there. Now, if you remember what these look like, you can just complete the sketch. Let me go to the actual formulas, and basically this is what you're looking at. So this is an actual cardioid. I can't even pronounce it correctly, but that's the basic shape that you're going to obtain. Now, in this particular one that we're actually graphing, the shape of it, it's actually going to be something along these lines. So it's gonna do this, and then it's actually looping at the bottom and doing that. Now all I need is a total of 3 coordinate points, and then complete them. I do need you to take a look at the homeworks, any variation of this one, but that would actually be it for this one. Obviously not to scale. These tend to be really messy, especially if you have constants or fractions embedded in there. So this represents r is equal to 1 minus cosine of theta. And then on Wednesday, we'll take a look at how to use technology to graph some of these.